Okay, so this is factors of the last term. Factors of 10 would be 1, 2, 5, and 10. Those are all plus or minus. And then factors of 2 in the denominator, so plus or minus 1 and plus or minus 2. You're going to write out all the different factors of those. So start with the integers that are over 1, plus or minus 1, plus or minus 2, plus or minus 5, and plus or minus 10. Then all those are being divided by 2. Well, 10 over 2 is 5. I've already got that. 5 over 2 I need. 2 over 2 is 1. I already have that, but 1 over 2 I need. So plus or minus 1 half and plus or minus 5 halves. Factors of 8 divided by 4. Factors of 4. So this would be 1, 2, 4, and 8. All those plus or minus. And then 1, 2, and 4. All those plus or minus. Start with the integers all over 1, so plus or minus 1, plus or minus 2, plus or minus 4, plus or minus 8. All these over 2, so 8 over 2 is covered, that's 4. 4 over 2 is covered, that's 2. 2 over 2 is covered, that's 1, but we have 1 over 2. All over 4, 8 over 4 is 2. 4 over 4 is 2. 2 over 4 is 1 half. We have covered, but 1 over 4 we don't have. This one says find all the zeros. You may use your TI Inspire to find the rational. Okay, so let's graph this. Looks like we have a couple of solutions there, one at 3 and one at -4. So x equals 3 and x equals -4. You could always do a trace. Oh, I probably should have listed out the possible rationals. That would be plus or minus 1, plus or minus 2. 3 does go into 48, plus or minus 3, plus or minus 4, plus or minus 5, 6, and plus or minus 8. So 12 would have to be in there, 16, and 24, and 48. So those are certainly part of that list. That's good. So I'm going to do some synthetic division here. Let's take out the 3 first. So let's divide out the 3. We get 1, 1, -8, -4, and -48. Let's see if this works. 3, that's a 4. That's 12, that's 4. That's 12, that's 16. That's 48, that's good. That's 0, remainder. In the box there, only go up to where the remainder is. And we're going to put -4 in the box. Divide that out. Hopefully get this down to a quadratic. That's the goal. Okay, so this is our x. This is our x squared. So we get x squared plus 4 equals 0. Solve that. You get x squared equals -4. Square to both sides. Don't forget plus or minus. X equals plus or minus 2i. And then x equals 3 and x equals -4. Those are my solutions. I got those from the ones we got from the graph there, the rational ones. Okay, let's graph this one. Okay, let's graph number 4 now. So 4 looks like this. Not a bad idea to list out the possibles, plus or minus 1, plus or minus 5. Oh, wait. This is plus 0, right? So I think you might want to factor that out first. Negative 19x plus 5. So I know we have a 0 at 0 because of this. Now that's a constant. Before it wasn't a constant, so I couldn't really do that. So Now I know there's going to be solutions at plus or minus 1 or plus or minus 5, possibly. Those are the possible rational. I know 0 is a solution for sure because I factored it out. So it does cross at 0. You can probably see that. It does look like at negative 5 it has a solution. So I think the other one's at negative 5. You can always use trace to double check that. So I've already taken out the 0. Let's just start with this and take out the negative 5. So negative 5 in the box. I already took out, so 1, 1, negative 19, and 5. So 1, negative 5, negative 4, 20, 1, and negative 5, which is 0. It's x squared. So this is a quadratic, so we get x squared minus 4x plus 1 equals 0. We're going to do the opposite of b, so that's 4 over 2a plus or minus square root of 16 minus 4ac. So this is 2 plus or minus square root of 12 over 2, which is 2 plus or minus 2 root 3 over 2, which is 2 plus or minus root 3. And then, of course, also solutions at x equals 0 and x equals negative 5. Okay, let's try this next one. So possible solutions 1, 2, and 4. It does look like when you graph it over here on the right, it has a solution at negative 2. So I'm going to take that out. So negative 2 goes in the box. 2, 1, negative 4, 4. It's negative 4, negative 3, 6, 2, negative 4, and 0. Okay. So I have a quadratic. I have 2x squared minus 3x plus 2 equals 0. This looks like a bit of work here, so let's see what happens. So x equals the opposite of b would be 3 over 2 times 2 is 4, plus or minus. All over 4 square root of b squared is 9 minus 4 times 2 times 2. So we get 3/4 plus or minus 9 minus 16 is negative 7, so square root of negative 7 over 4. So we get x equals 3/4 plus or minus I root 7 over 4. And also x equals negative 2. Those are our solutions. We got that one from the graph. Okay, let's see what this one looks like. Okay, so now we have a polynomial of degree 3, so x cubed. So I know 2 of the solutions, but I actually know one more. It's going to be at negative 4i. So you write the 3 factors. So this will be x minus 2, x minus 4i, and x plus 4i. So this first one we're going to wait to multiply. And we're going to FOIL this guy. So this would be x squared minus 4i plus 4ix. Those go away. Minus 16i squared, so that's plus 16. And then we're going to FOIL that together to get x cubed minus 2x squared plus 16x minus 32. That is one quadratic or cubic that has all those solutions. Just find the x and y intercepts. Well, that should be easy to find the x-intercept or y-intercept, plug in x equals 0. So if you do that, you get y equals 0 over 5, which is 0. So a y-intercept at 0. And if you do this for x, 0 equals 2x. You don't have to worry about the numerator, denominator. It's going to go away. You get 0 equals x. So x-intercept at 0 as well. So they're both cross at 0, 0. So it's the x and y-intercept. So this one, let's see what happens. So we set x equal to 0, we get y equals 3. So y-intercept at 3, and 0 equals 3. That's not true. Therefore, there is no x-intercept. Horizontal and vertical asymptotes. Okay, so vertical asymptotes at x equals 3 and x equals -1. Wait, there's going to be a hole. That was sneaky. Almost didn't see that. It's going to be a hole at 3 comma something. We're going to have to plug that in. So to get that, we're going to plug in, after we cancel, we're going to plug in 3 there. So we get 3 times 3 plus 4 is 7 over 2 times 3 plus 1 is 4. You get 21/8. Wow. That's where your hole is. And then your ha, it's same degree, so it's going to be y equals 3/2 because you're dividing the coefficients there. Okay, this one, you want to factor it first. So I would do that, x plus 4 over x minus 2 times x plus 2. So we have vase at 2 spots at x equals 2 and x equals -2. We have ha, let's see, horizontal asymptote, it is bottom heavy, so it is y equals 0. Okay, let's try this one. These can get tricky sometimes. Definitely want to factor the numerator. Let's try to factor that. So let's see what happens here. So let's say one of them is x minus 2. I just have a gut on this. So if it does, that would be 2x plus 3. Does that work? -6, -4, 3. That does work. Okay. X minus 2 cancels. So we really have y equals 2x plus 3. But there is a hole, so there's no asymptote. There's a hole at 2 comma something. If I plug in a 2 after I cancel out 4 plus 3 is 7, so 2 comma 7, there's a little hole right there. And the graph is just linear, but there's no asymptotes, right? So 2x plus 3 kind of hops over that point and keeps going. So that's the hole in the graph. Pretty nifty. Okay, so this one. This is not bad. You could do this. This is a kind of a parent function transformation. It's going to move, it looks like, to the right 2 units. So I'm just going to graph it that way. It just seems easier. So x equals 2 is my vertical. It's bottom heavy, so y equals 0 plus its quadrant. It's not a bad idea to find the y-intercept. That'd be -1/2. I know it's going to be bottom left and top right because it's a transformation of the parent graph. Try this one. So we have 2 vertical asymptotes, one at x equals -3. And one at x equals 1. And it's bottom heavy, so there's one at y equals 0. And let's find the y-intercept. If you plug in x equals 0, you get -2, so y equals -2 over -1 times 3, which is positive 2/3, right about here-ish. And just double checking, there is no, so 0 equals x minus 2. Oh, wow. That's interesting. So x equals 2. I didn't expect that. I thought there might be no x-intercept, but there is at 2. weird. Okay, so I know in the middle it's confined to these quadrants, something like that, because it goes through that y-intercept right there. I don't know what happens. Wow, so kind of interesting here. So I might have to plug in 2 points. I don't like to have to do this. I had to plug in 3 points on this graph. This is really tough. So man, I did not give you an easy one. So 1.5. Let's plug in 3 also. Let's plug in -4. If we plug in those points, we should have enough to go on for sure. So 1.5, and all I care about is these are positive or negative, really, but it'd be -0.5 over, let's see, if I 0.5 times 4.5, half of 4.5 is 2.25. So it's 1/2 divided by 2.25, which is 9/4, which is 2/9. It's definitely positive. So somewhere up here. So this graph's doing this, I think. Plug in 3. I want to see if it crosses. My guess is it crosses, but it might not. I don't know. 3 minus 2 is 1. 1's in the numerator. 3 minus 1 is 2. 2 times 6 is 1/12. Wow, it goes up to 1/12. So my guess is it does this. It kind of approaches. So it bounces and approaches the asymptote. The asymptote will approach the asymptote as it gets towards infinity. Wow, it's a really weird graph. And then plug in -4, we get -6 divided by -5 times -4 plus 1 is -1. So I get -6 divided by 5, -6 is negative. So I think this one looks like this. Okay, looking at this, I realized I forgot a negative. 1.5 minus that is negative, so this is -2/9. So this is not the graph here. It definitely is -2/9 at 1.5. So it does kind of start low and then kind of comes back down there. You can see it right there on the graph if you kind of see, oops, if you're in trace mode here. You see you're a little bit above 0, and then it comes down towards 0 there. So I just had a negative wrong there. So easy to do, especially when you're plugging in a decimal there. Forgot the negative. Okay, this one, factor first if you see some. So I see some. I don't know if that'll help. Okay, so vertical asymptote at x equals 2. Horizontal asymptote, same degree, so 2 over 1, so 2. Y equals 2, I should say. Y-intercept would be at 4 over -2. So which is -2 is the y-intercept. X-intercept is going to be y equals 2 times, or sorry, 0 equals 2 times x plus 2. So we get 0 equals x plus 2, or we could have just solved that right there. X equals -2, so that's the y-intercept. It's -2, so I know this graph looks like this, bottom left. And then it doesn't cross the x-axis, so it's got to be top right. That's nice. Almost done. So a couple more here. So this one, be careful. This is actually a factor there. So you're going to have one vertical asymptote at x equals 0, one at x equals -3, And same degree, top and bottom, so it's going to be y equals 1 is the coefficients there. So y equals 1. And let's find the y-intercept. There's not going to be one, but x-intercept, I think there will be. So that would be 0 equals, just put it equal to the numerator, x minus 2 times x plus 3. So x equals 2 and x equals negative 3. Oh, don't cross those out. That's going to be a hole. Oh no. Let me, sorry, I've got to get rid, I don't have a way to erase using this method I'm doing here. So I'm going to, I just didn't see that to start with, but there's a hole there. So there's a hole at negative 3 comma something. I've got to plug that in to see what it is. So my new equation is y equals x minus 2 over x. So if I plug in negative 3, I get negative 5 over negative 3, which is positive 5/3. So negative 3 comma 5/3 is like right about there. There's a hole in the graph. And so there will be still a horizontal asymptote at y equals 1. That's still true. Same degree, so divide the coefficients, so y equals 1. And then if you set that equal to 0, so 0 equals x minus 2, so x equals 2. So we have a x-intercept there, so I know this part of the graph looks like this. And it's got to be top left because it goes through that hole. So like that. And it's one definitely factor first. We're almost done here. So vertical asymptote x equals 1 and x equals negative 1. So it's more straightforward. It's bottom heavy, so y equals 0. Y-intercept would be at positive 1. X-intercept, there is none. So it's got to be confined up there to the middle. Probably looks something like that. Plug in 2, maybe negative 2. Sorry, x and y. 2 and negative 2. So if I plug in 2, I get negative 1 over 3 times 1. So that's negative. So it looks like this. And if I plug in negative 2, I get negative 1 times negative 3, which is negative 1 times negative 3 is positive 3, negative 1/3 also. So it's going to be down over here. And you got it.